In this video, I'm going to go through IGCSE indices, specifically simpler questions that tend to appear in the first half of the higher paper. So a question might say, leave your answer in index form. That means it wants a big base number and a little power. So leave your answer in index form. The question can also be worded differently. The first one says, leave your answer as a power of 3. So you're going to have 3 to the power of something. When we multiply and we have the same base number, which is 3, we add the powers. So 5 add 6 gives us a power of 11, and it's 3 to the power of 11. So the base doesn't change. And that is the same whether the base is a number or, as in question 2, the base is a letter. The base is not going to change. Now the second y doesn't have a power. That means that there's an invisible 1. And again, because it's a multiplication, we are going to add the powers. 4 plus 1 gives us a power of 5. So the answer is y to the power of 5. Again, this says leave your answer as a power of 5. So they want you to put 5 to the power of something. This time the base is 5. The base doesn't change. We are dividing, so we are going to subtract the powers. 8 minus 6 is 2. Now note the order in the subtraction matters. So if you had 5 to the power of 6 divided by 5 to the power of 8, you would still subtract, but you would subtract 6 take away 8, and the answer will be negative 2. And they might ask you to simplify further. They might say, in this case, leave your answer as a fraction. A quick and easy way is to put that into your calculator, and you will get 1/5. The negative power turns this number into its reciprocal, 1 divided by the 5, the base, to the power of 2, because it's to the power of 2, and it becomes a positive power. And 5 squared, 5 to the power of 2, is 25. Not 10, it's 5 times 5. But again, if it's a number, and it is a number here, you can put that into your calculator. So you can say 5, and you can use this x with a little box for the power to the power of, and you type minus 2 and equal, and it gives you a 1/25. Next question, simplify. You've got a multiplication at the top, and then the fraction means a division. So to start with, we are going to add the powers. So that gives us x to the power of 15. And then we are dividing by x to the power of 4. So we add the powers on top, and then because it's a division, I'm going to subtract the powers. The base, which is x, stays the same, x to the power of 11. This is quite a common question. It gives you one of those fractions, but one of the powers is missing, and it says find the value of n. Now, all these powers are connected. So if I highlight all the powers, the 3, the n, the 2, and the 10, they are all connected. First thing I need to do is add those powers. Why am I adding? Because of the multiplication. So I have a 3 plus n. But what happens next is I'm dividing, of course. This is a division. So I subtract the 2, minus 2. So this power, 3 plus n, take away 2, is going to equal, because of this equal, to 10. Because that's the power at the end of the calculation. And then we answer the question. 3 take away 2 is 1. That means 1 plus n equals 10. That's an equation, a very easy equation that you can solve. Take away 1, take away 1, so n equals 9, 10 minus 1. And I found the value of n. Usually in the exam paper, they will give you something that looks like this. N equals ... and you need to write there 9. This is usually a very simple 1-mark question. Find y to the power of 0. Anything to the power of 0 equals 1. Whether it's a number, 5 to the power of 0 equals 1, or letter. And if you're not sure, if you forget, but you shouldn't, you get your calculator, and yes, it says y, but y represents any number. So you get your calculator and you put 9, for example, or any number you want, to the power of 0 equals, and it will give you 1, so you can check. Now we get to our powers and brackets. The first thing you need to remember is, I'll put a slightly simpler one. If you have 3 squared all to the power of 4, the base doesn't change because there's only a base, and those two powers are multiplied. So it becomes a 3 to the power of 8. Again, if you had a y squared to the power of 5, the y doesn't change, and those two are multiplied. So that's to the power of 10. But these questions here and the ones below are a bit more complicated because you actually have 2 separate bases. You have 2, you have x, and then you have the powers. And the power of 3 is actually attached to this base. So x cubed is all raised to the power of 4. So this is how I want you to write it. This power at the outside the bracket is applied to both parts inside the bracket. That means 2 is to the power of 4, and then the x cubed is to the power of 4 as well, which is like this one here. And then you answer it. 2 to the power of 4 you can do with a calculator. 2, and then you use the power button there, to the power of 4 equals 16. And then you remember that those two powers are simply multiplied. So that's x, don't forget the letter, 3 times 4 is 12. And that is your final answer. Again, a similar question, except the power is a negative. You've got 2 separate bases here. You've got 2 to the power of negative 2, not just 2, but negative 2. And then x squared is also to the power of negative 2. Again, for the number, you can use your calculator. 2 to the power of negative 2 gives you a quarter. And then those two powers are multiplied, and so you have x to the power of negative 4. And of course you can use your calculator for multiplying the powers as well. Question 4 gets a little bit more complicated. You've got 3 parts. You've got 64, you've got x squared, you've got y cubed, and then the power is a fraction, it's a half. What the power outside the bracket is applied to every part. It's applied to the 64, it's applied to the x squared, it's also applied to the y cubed. So let's write this: 64 to the power of a half. X squared to the power of a half. Y cubed to the power of a half. And again, you would get your calculator and you would type in 64 to the power, so use the power button, and then use the fraction button there and type in your fraction and use your arrow to go down, and that's it. 64 to the power of a half gives us 8. And then those two powers are multiplied, 2 times a half. And again, you should know this, 2 times a half. And if you're not sure, you can use your calculator. 2 times a half is 1. So you can write x to the power of 1, but you don't have to, just x. And again, those two are being multiplied, and you get 3 times fraction button, and you type in the half, which is 3 over 2, and write y to the power of 3 over 2. So each part gives you an answer. 3 parts to your answer. And this is the final example. You've got 2 parts inside the bracket, but you have got a negative and fractional power. Now, the first thing that you have to remember with the negative is that it turns it into a fraction. So instead of 64 y to the power of 4, you now have 1 over 64 y to the power of 4, all to the power of a positive 2/3. Especially if they want it as a single fraction, that would be a much better way of thinking about it. The other way of thinking about it is to say, well, 64 is to the power of negative 2/3, and y to the power of 4 is also to the power of negative 2/3. And I'll show you what happens using the calculator. When you put 64, I'm going to use the power button. I'm going to type my minus first, then I'm going to use the fraction button, and I'm going to type 2/3. 1/16. So it turns it into a fraction. And then you can multiply those together 4 times. So 4 times negative 2/3. So it gives you, I'm going to write y to the power of negative 2/3. So that's one way of doing it, if you want to apply exactly what we were doing before. It gives you 2 separate parts. This method here is going to give you 1 fraction. So you need to remember that this minus turns this into a fraction. And then you're going to split it apart like we usually do, 64 to the power of 2/3, and y to the power of 4 to the power of 2/3. 64 to the power of 2/3 is 16. And then it's y to the power of 2/3. So that answer is exactly the same as that answer, but that's a fraction, and that's still got a power. Often they don't specify, and a lot of the time they will accept both. So whichever one you find easier to do, you can do. I'm going to put actually one final example here as well. I'm going to use similar numbers, so we want to simplify. And I'm going to have a fraction, so I'm going to have 25 y to the power of 6 over 81 x squared, all to the power of negative a half. So you've got that negative again. Now when you have a fraction, the negative turns the fraction upside down. So the 81x squared is going to be at the top, and the 25y to the power of 6 is going to be at the bottom. And then we're going to apply the positive power of a half, because the negative has done its work. It's turned it upside down. So that's why now the power is positive. And then this power outside is going to be applied to every single part. The 81, the 25, the x squared, and the y to the power of 6. So this is how I'm going to write it. 81 to the power of a half, x squared to the power of a half, over 25 to the power of a half, y to the power of 6 to the power of a half. Remember, those two powers are simply being multiplied. So I'm going to get x to the power of 1, and you don't need to write the 1, and I'm going to get y cubed. 6 times a half is 3. Now 81 to the power of a half is the square root of 81, which is 9. And 25 to the power of a half, and you can do that on your calculator, is the square root of 25, which is 5. And that is your answer. It is good to learn the laws of indices. Negatives will either give you a fraction, or they will turn an already written fraction upside down. And anything to the power of a half means the square root of that number. Anything to the power of a third means the cube root of that number, etc. So anything to the power of a quarter is the fourth root of that number. And when that changes and you have 2/3, for example, it's the cube root of the number squared. So that is your root, and that is your power over there. So that is very quickly GCSE indices.